Hi. Welcome to Introduction to Python Programming course. It is Module 1 of the 3-module Python course. It is conducted by Subburaj Academy for the benefit of students, in particular. Before we proceed, make sure that you have carried out programming as I did in the previous lessons. If not, stop, go back to the previous lessons. You must complete assignment 1.4 before we proceed. We are in lesson 14. Recursion. So far we saw a function calling other functions. Now we will see how a function can itself. Function calling itself is called recursion. GCD is the greatest common divisor that will divide both the given numbers evenly. The popular Greek mathematician Euclid developed the algorithm for the same. Hence, this algorithm is also known as Euclid's GCD algorithm. This problem can be solved both recursively and non-recursively like the other functions we saw. Recursive GCD algorithm is as follows. GCD, m, n. If n equals 0, return m. Else, return GCD, n, m%n. Main. 1. Get the two numbers. 2. If n greater than m, swap m, n. 3. Result equals GCD, m, n. 4. Print result. The algorithm has been converted into a program in this slide. In the main function, two numbers a and b whose GCD is to be found is received, at lines 13 and 14 respectively. At line 15, if b is greater than a, then the numbers are swapped to ensure a is greater than b. Let us say a is 14 and b is 42, after swapping a will be 42 and b 14. Now in the main function, we call GCD, 42, 14, and assign it to result at line 19. Now the control transfers to the GCD function. Their 42 will be num1 and 14 num2, in the above case. At line 5 we check whether num2 equals 0. Since it is false, control goes to line 8. It returns GCD, 14, 42% 14 equals 0. Now control goes to line 4. At line 5, since num2 equals 0, it returns num1, which is 14, to the called function, which is main. This is assigned to result in line 19 and printed in line 20. This is how the program works. The results of the program when executed twice is shown in the slide. Note GCD of 256 and 32 equals 32. GCD of 91 and 26 equals 13. The algorithm for finding factorial of a number recursively is given in the slide. The algorithm forces the user to enter a positive number for finding factorial. If n equals 0, then factorial is 1. If not, we return n asterisk fact, n1, recursively. Always write the algorithm first and then convert it into a program. The recursive factorial program is here. The program also forces the user to enter a positive number for finding factorial. If n equals 0, then factorial is 1. If not, we return n asterisk fact, n1, recursively. Count the number of return statements in the program. In the main function, we tell the user to enter a positive number whose factorial is to be found. Then as part of the print statement we call fact, num. Look at both the functions GCD and fact discussed. In both the functions, the recursive call to the functions are made at the end or tail of the functions. Hence such recursions are called tail recursion. The result of the program may be seen. Factorial of -7 equals none. Factorial of 0 equals 1. Factorial of 1 equals 1. Factorial of 10 equals 3,628,800. Factorial of 100 is such a large number. In mathematics, the exponential value of a number is equal to the number being multiplied by itself for a given number of times. The number to be multiplied by itself is called the base, and the number of times it is to be multiplied is the exponent. Python allows users to calculate the exponential value of a number in several ways. Using asterisk operator. Using built-in function pow. 3. Recursively as per the algorithm given here. Receive a base and an exponent and find the exponential value using recursion. Remember, the exponent value should be an integer to avoid runtime issues. The algorithm for finding recursion is as follows. Algorithm. 1. In the main function, receive the base and exponent from the user. 2. Pass the numbers as arguments to a recursive function expo, base, pow, to find the power of the number. 3. Give the condition that if the exponent value is equal to 1, return the base number. 4. If the exponent value isn't equal to 1, return the base number multiplied with expo, base, pow 1. 5. Print the final result. 6. End. Study and note the following in the program. The user enters the base and exponent value. The numbers are passed as arguments to a recursive function expo to find the exponential value. A condition is given that if the exponent is equal to 1, the base number is returned. If the exponent isn't equal to 1, the base number multiplied with the expo function is called recursively with the arguments as the base and exponent value minus 1. The final result is printed in the main function. Note that the exponent has to be strictly integer. Result of the program is given here. 3 to the power is 81, which is correct. The Towers of Hanoi is an interesting puzzle. In this puzzle, there are 3 towers called source, destination, and temp. The source is stacked with several circular disks with varying diameters. Each disk has a hole in the center through which the disks can be inserted in the towers, in other words, poles. The source is stacked with the largest disk in the bottom and the smallest disk on top as shown in figure. The other 2 towers are empty initially. The game is to transfer the disks from source to destination by observing the following rules. A. Only one disk can be moved at a time. B. We cannot place a disk of larger diameter on top of a disk with a smaller diameter. C. The disk removed can be put only on one of the 3 poles. Immediately. Not even temporarily on an additional pole or ground. Let us try to evolve the algorithm through examples. In the simplest case, there are 2 disks. Disk 1 is on top and disk 2 at the bottom. The following steps are involved in the transfer of the disks from source to destination following the rules. 1. Transfer 1 from S, source, to T, temp. 2. Transfer 2 from S to D, destination. 3. Transfer 1 from T to D. Let us now assume 3 disks in the source, one top of another as given below. The diameter of disk 3 is larger than 2, which is larger than 1. Disk 3 is at bottom. Disk 1 is at top. Disk 2 is in middle. The steps involved in transferring the 3 disks from source to destination by observing the rules are given below. 1. Transfer 1 to D. 2. Transfer 2 to T. 3. Transfer 1 from D to T. 4. Transfer 3 from S to D. 5. Transfer 1 from T to S. 6. Transfer 2 from T to D. 7. Transfer 1 from T to D. A transfer of 2 disks takes 2 to the power of 2 minus 1, in other words 3 steps. The transfer of 3 disks took 2 to the power of 3 minus 1, in other words 7 steps. We have followed a set pattern. Observe that when there were 2 disks, we transferred the largest disk at step 2 from source to destination. There were 3 total steps. When there were 3 disks, we took 7 steps, and exactly at the 4th step we transferred the largest disk from S to D. Therefore, if there are n disks, divide the problem into 2. Step 1, transfer n1 disks from source to temp. Step 2, transfer the nth disk to the destination. We see from the examples that when the nth disk is transferred, the n1 disks are at temp stacked in proper order. Now the task is to transfer the n1 disks from temp to destination using source as the temp. The second step can now be solved recursively. Here is the Tower of Hanoi algorithm. Hanoi, n, s, d, t. If n equals 1, move disk from S to D. Else, Hanoi, n1, s, t, d. Move n from S to D. Hanoi, n1, t, d, s. End. The Tower of Hanoi program is in the slide. XFER is the name of the function. The n is the number of disks. The s is source. The d is destination. The temp is the intermediate pole. Some points to be noted in the above program are given below. The program in the main function asks the user to enter the number of disks to play with. The number entered should be a positive number. Then the main function invokes the function XFER and passes the value entered by the user. In the XFER function, if the number of disks is 1, then the disk is transferred from S to D. If the number is not 1, the else block is invoked and the problem is solved recursively. The main function calls XFER function with 4 parameter, n being the number of disks proposed by the user. We have divided this program into 2 parts and will continue to subdivide it till conquering. This strategy is known as divide and conquer, which is a very useful technique in solving complex programs. The Towers of Hanoi problem is a good example of recursion and divide and conquer, both. Carry out assignment 1.5 just after completing this lesson. This slide completes Module 1 Introduction to Python 3 Programming. For learning more about Python, sign in for Module 2 of the course, Object-Oriented Programming with Python 3. Thank you for watching. Until we meet again, bye.